Hey boys and girls, I'm here today to introduce the Magnetic Racetrack Challenge to you. This is a loads of fun and you're going to have loads of learning. We're going to be covering things like area, perimeter, time, informational text, and invisible forces. So let's get started. So let's talk about the problem. You know, engineering, I always start with the problem. And the kind of problem you have is the kind of engineer you're going to get. So let's look at it. Let's take a look. So one type of engineer who studies and uses magnetism is a mechanical engineer. Mechanical engineers research, design, develop, and test tools, engines, and all kinds of mechanical devices. Scientific toy company is looking for mechanical engineers to design a toy car racetrack that can move a car around a racetrack in 30 seconds or less using the force of magnetism. Your challenge is to design and construct a toy race car track that uses magnetism to move the car around the racetrack in 30 seconds or less. And here's the catch. You cannot touch the magnet, you cannot touch the car, and your guiding magnet cannot touch it either. So it's got to be moving through invisible forces. Let's talk about criteria and constraints. So criteria and constraints. Criteria is your what do you need to do to be successful? What's your success criteria? And your constraints are kind of like your rules. What did your boss put onto you? Like, do you have money constraints, time constraints, those kind of things? So first of all, the racetrack must be constructed from one piece of graph paper divided into 4 equal parts, and then mounted on a sturdy material. So I'm going to show you just a quick example. You're going to take a piece of paper like this, and you're going to fold it in half, and you're going to fold it in half to get quadrants. So when I open this paper up, I have 4 parts. 1, 2, 3, 4. So those are fourths. They're considered quadrants. Okay, so you're going to take this piece of paper and you're going to mount it onto something sturdy, like a piece of chipboard or cardboard or something sturdy. You are going to elevate the racetrack so the players can use the bottom side of the racetrack to move their cars. This is an optional piece, but let me show you. You have, like, this is a sturdy material. This is like chipboard right here. If you mount this on here and you glue it down, you can elevate the bottom, like with rocks or corks or something, and that way you can move the magnet underneath. That's one way to move that magnet around without touching it. So that's optional, but just remember, you can also put this between 2 desks, or you could just fold it up and be able to use magnetism going through those materials. You need to guide the racetrack car without actually touching it. Let me just show you. Here is, you guys are going to be getting a car that looks like this. It's foldable. You're going to cut on all of the solid lines until you get this, and you're going to fold on the dotted line. So you can look really closely. There's dotted lines. And when you end up folding it, you're going to use a little glue, and it's going to stick together. And you're going to see how this starts to come together. Okay, so you're going to end up with a little race car. This is where you want to put a magnet, and you definitely want to tape that in, maybe on the very back piece of it. Tape that down so you can push it with your magnet. All right. So anyway, that car, when you're pushing it, you can't touch it. You're going to have a wand. So you have a wand and a magnet inside the car. These things cannot touch each other. So you're going to use either an attract or repel force to push that car around the track. Your car must change direction 4 or more times while moving through one quadrant of the track to the other, and all 4 quadrants need to be used. So all 4 parts of this, your track needs to go around all 4 parts, and it needs to have at least 4 turns. So I could see, if I did a regular racetrack, I would turn 1, 2, 3, 4. Or you can make something unique. But remember, you have 30 seconds that you need to get your car through there without touching the car at all. All right. You know, with any good testing, you definitely want to test more than once. So you're going to You're going to do this race 3 times and you're going to time it. So I'll have timers for you. A partner can time it while you are going through the racetrack. Chart your results, and we'll talk about a couple pages down. And on your racetrack, you need to know the area and perimeter of this racetrack. Okay, and so what you can do is you can find the area and perimeter, or the area of one quadrant right here, the area of this, and then it's going to be the same as this, same as this, same as this, because they're equal parts, so you can add those together. So area is length times width. Remember that. How long, how wide, and then times 4. Okay? And perimeter, you can just count around, count all the boxes around the whole edge. This is the perimeter. Just count those boxes, or you can add double the 2 sides here, plus doubling the 2 sides there. So, all right, that's it for your criteria and constraints. So I think that's clear. Let's go on to the research and imagine. So in your textbook, you have a read called Investigating Magnetism from Unit 10, Week 3 in Benchmark Advanced. I want you to read that with your class. So we do that whole group, or with your teacher. That gives you some background knowledge of magnetism, and you're going to get some language art skills out of that. You guys are going to collaborate with your group to come up with multiple possible solutions. Each person should sketch an idea, and then you can choose the best idea. So this is how I do it. Each person get one piece of graph paper and come up with your idea. You know the constraints. You know you have to have 4 equal parts. You know you have to be in each quadrant. You know you have to have 4 turns. So everybody come up with their own design, and don't spend too much time, maybe a few minutes, and then show them to each other. Show them to your team and talk about what do you think the good parts of each other's design were, what parts do you think you definitely want to keep, what parts can maybe you take away. Maybe you can combine some of your best ideas to make one design. So once you do that, choose that best design and then record it here. So this is going to be your final design. And I'm going to change this to plan because that's plan. Oops, plan. In the engineering design process, we call it more of the plan, but this is where you're doing your designing. So go ahead and design this out. Your racetrack is going to go around. Make sure you start with make sure you have a start line and a finish line. Make sure you know where that is. Okay, mark it clearly, label it, start and finish on your track. All right, so after you have your design ready, you can use the available materials to create your racetrack. So on your racetrack or somewhere on it, I want you to make sure that you write the perimeter and write the area and have your name on there. Okay, so you can put something like A equals, P equals, have those things on your racetrack for us to see. Let's see. Yep, I already said label your start and finish line for sure. You guys can use small graph paper or large graph paper. You're going to have your foldable card. You're going to have magnet tape. Those are all your materials listed out. That's what you need to complete this. Once you have that done, you're going to go ahead and start testing. So you can see on this page, there's going to be a place for each of the racers' names to be recorded into. So you can have up to 4 people on one project. So each team member should race their car 3 times while a partner times them. Another partner should record their times in the appropriate chart below. You guys are getting your own charts. Please put your name on it. And you need to calculate your own results. So when you're doing an average time, or when you're adding up your time over 3 tests, I want you to add all these times together and put the total time that you were racing. Okay, how long did it take you? It might have been faster than 30 seconds. It might have been longer. Remember, our goal is 30, but it could be faster or longer depending on how fast you can get through it. All right, so now that you've gathered some data, let's go ahead and do some engineering talks. You guys, I want you to use Flipgrid for this. So I want you to do an interview. I want you to interview one of your teammates and decide like who's going to ask the questions, who's going to answer the questions. And maybe it's a combination. Maybe you take turns answering and asking. But here are your questions. I want you to do it on film, on Flipgrid. Flipgrid you can find in Google Classroom. Practice before you film. So definitely run through the questions, talk about what you want to say, and then go ahead and film it. And I put some academic vocabulary down here, and those are the words. I want to see those words in your conversation. Okay, we want to see that academic vocabulary, and you know what you're talking about when it comes to magnetism and when it comes to the math that we did, and also just the engineering design process. Okay. All right. I hope you guys had fun with this. I know it's a quite a fun experience doing an engineering challenge, and enjoy.